Hey guys, we're going to do 6-1 homework. So after you take notes on these sections in class, and any notes you might get off of here, then you're going to do your 6-1 lesson check. Make sure you do your 6-1 discussion, right? We're back to the groove. And we have our 6-1 homework. So this is a little different. I'm actually squishing together more sections than in our workbook, but in chapter 7, we'll go back to our workbook. Okay, so this looks familiar though. These were the types of things we reviewed for the test. So this is definitely a Florida standard, and these are like the ones we practiced. So let's take a look. It says, provide the sum of the interior angles of each of these. Okay, so first, I kind of would like to, n equals the number of sides. All right, that's what we need. So this here would be 8, right? Quadrilateral is 4. Decagon is 10, and pentagon is 5. Okay, so the formula from our notes, the sum of the interior angles, the sum of the interior angles would be this formula. So that's why I need to know n. Okay, so let's go back here and use the formula. The sum is equal to 180 times n minus 2. So I'm going to plug in 8 for the first one. I'm going to plug in 4 for the second one. I'm going to plug in 10 for the third one. And I'm going to plug in 5 for the last one. Okay. Then we're just going to do a bunch of number crunching. 180 times 6. 180 times 2. 180 times 8, right? 180 times 3. Okay. And we kind of already knew that all quadrilaterals add up to 360 because 90 times 4 is 360. And there we go. All right, what's the value of A? So again, we need to make sure, is this interior or exterior? And we notice these are all inside of our polygon. So we can use this same formula, 180 times n minus 2. So what's n? We got 1, 2, 3, 4, 5. Okay, so n is 5. And so we already got that up here, but we'll just go ahead and do it anyway. 180 times 3, we said, is 540. So these numbers all have to add up to 540. So 1, 2, 3, 4, 5 numbers all have to add up to 540. So it's a lot of number crunching. All right, so let's just double check that. Right? Now we can solve, right? So subtract 45 on both sides. Nice, 55 degrees. Now make sure anytime I get multiple choice on a homework, make sure you show your work. Okay, number 3, select all that is correct. So the measure of each angle in a convex regular with interior angle sums of this would be 140. All right, so let's take a look. If S adds up to that, let's figure out what n would be. So if S adds up, so 180, n minus 2. If that was equal to 1260, we can use algebra to figure out what n would be. So let's see, what's 1260 divided by 180? 7. Okay, add 2 on both sides. So n is 9. So what would be the measure of each angle? So if the sum is 1, and we divide by n, then that would be each angle. So 160 divided by 9. 1260 divided by 9, I get 140. So I'm going to say yes, that is a correct statement. The sum of the interior angles of any 7-sided is 900. I'm going to say yes, that was in our notes, right? The number of triangles formed by drawing diagonals from a vertex in a decagon is 8. That's yes. So they're like, what do they mean by that? What they mean is, in this formula, n minus 2, that'd be, if n is 10, then this number would be 8. That's the number of triangles that would be formed. And I think most classes I showed this. Now, it's hard to show with a decagon because a decagon has a lot of sides. But if I started at one vertex and counted off how many times I could make triangles just using no interior vertexes, and drawing a web, I could make 8 triangles out of a decagon. That's why this is minus 2, because these 2 perimeter sides would be retraced. So if I had 10 vertexes, I could trace to those sides and create 8 triangles. And that's why this formula is 180 times 8, because a decagon would create 8 triangles. All right, D, if 2 polygons have the same number of sides, okay, so then the sum of their interior angles is the same. Yes. So I think we looked at trapezoids and rectangles, right? These 4 angles add up to 180. These 4 angles have to add up to 180, or excuse me, these 4 angles add up to 360, right? And these all add up to 360. So just as long as they have the same sides, they should all add up to the same number. There exists a convex quad, so that's 4 sides, with 3 equal sides. So let's make 3 equal sides. And one's different, so something like that. 3 equal sides, one's different. 3 equal, oh, they said 3 equal interior angles of 120. This one's a little different. Okay, so they're saying this would be 120. That's 120. And this is another 120. So 120 we said in our notes, that's like I'm going to make a hexagon, a 6-sided. 120, 120, 120. So I have 3 equal angles that are 120. Can I finish out that? And I'm going to say no. If I try to finish this out with 3 120s, 120 times 3 is 360. And I need more degrees left over for my 4th angle. So notice if I make all these 120, then I got to cut across here, and now this angle that was 120 is now no longer 120. So I could be okay with 2 angles that are 120, but the minute you make a 3rd angle 120, I have no more degrees left for that last angle. And I need 4 angles to make a quadrilateral. All right, number 4, determine the value of x in the hexagon. So n is 6, so 180, n minus 2. Right, so every hexagon, all their angles add up to 720. So these all need to add up to 720. So let me combine all these. I'm kind of skipping a step, but it's a lot to write out. So 3x, 2x, 2x, 3x, 2x. So 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 x's. Now I'm going to add up the numbers. 90, 20, 10, Oh, but there's a negative there, so I got to be careful. 5, 35. Okay, so 90, 35, 5, 10, and subtract 20. And all that should add up to 720 degrees. All right, let me double check that. All right, if I subtract that. Now again, I could plug this back in, but it should all be right. So that is my answer. Nice. Okay. So let's take a look at the questions on the back. Okay, this has to do with kites and trapezoids. So what's the length of BD? All right, I think this is just using the triangle things we knew from before. And maybe something we talked about today. So we said today that they needed a 90. So that means this triangle right here, this 3, 5 is a right angle. So I can solve for this part of it, right? 3 squared plus x squared equals 5 squared. And I think this is actually the most famous triangle of all time, so I actually recognize it. This would be a 3, 4, 5 triangle. So, okay, so I know this length is 4. All right, now I know this is 3, right? And I know that if I fold it over, it'll land on top. So that side's 3, okay? So now I can use Pythagorean theorem again on this other side. So this is kind of just using stuff we have learned in previous chapters. And I'm going to call this y. Let's solve for that. So I've got 3 is one side, so 3 squared, plus y squared equals 8 squared. So 9. All right, I get 55. I take the square root. So the square root of 55 is 7.416. Okay, so this is 7.416. It's a decimal, and this one's exactly 4. So when we add those together, then it rounds to B. Nice work. And if we look at our picture here, that actually makes sense. That's 4, and again, this is 8, then that looks a little bigger than 8. Number 5, find the area of the kite. Okay, so that's kind of interesting. We didn't really talk about areas today, but let's see if we kind of know how to do this maybe anyway. Okay, so here we go. The area I'm going to actually skip this one because I think we didn't really cover it. All right, I'm going to skip that one. Let's do this one. Find the length of the mid segments. Okay, let's see if this makes sense. This is 39. This is 2x plus 5. And it looks like they cut this in the middle. So this is actually kind of like our midpoint formula. It's just our average. This should be the average length. The black length is the average between the red and the blue. So how do we find the average? We're going to add the two red together, the red and the blue, right? And then divide by 2, and that should equal our average length. So you're like, well, how would that work? Well, if you got an 80 on a quiz and then you got a 90, you'd add them together and divide by 2. And you'd get a score of an 85. So the average of an 80 and a 90 is 85. And so it's exactly the same thing I'm doing mathematically. All right, so I guess my first step, I'm going to multiply both sides by 2 so I can get rid of this 2 here. And I'm going to distribute this 2, right? So I got 4x minus 6. All right, usually, what do we do here? Usually we're going to get all these x's on the same side. So let's subtract that. And now I'll add 6 to both sides. All right. Divide by 2 on both sides, and I get 25. You're like, wait a minute, that's not my answer, but it said find the mid-segment. Well, the mid-segment is the segment in the middle, and I'm actually not done. I can plug 25 in for x. So 2 times 25 minus 3. So 50 take away 3 is 47, and I do have an answer here, 47. A lot of algebra. Find the angle of the trapezoid shown above. Okay, so they want an angle AEF. Okay, this angle. All right, well, you know this is a parallelogram, so there's a lot of these. They're either skinny and they're less than 90 or bigger. So they want to know this angle here, okay? AEF. Well, if this is a trapezoid, that means these lines are parallel, right? Then these are supplements, and that's what we talked about today as well. The big angle, 110, and the acute angle is the angle we're solving, angle E, right? Have to add up to 180. So what do we get? We get angle E has to equal 70 degrees, and that is less than 90. Nice. Okay, we go to 9. It says, consider the isosceles. Okay, so that means kind of like what we've been doing when we fold it. That means that whatever's happening here on the left would fold right on top of the right side and vice versa. Okay, so this 40, if we folded it over, it would land over here, right? Same with this 30. If this 30 was folded, it would land over here. Makes sense? So it says part A, find the angle BAE. So that's happening at A. BAE. Well, interesting, right? Because if it's using the word trapezoid, we know the definition of a trapezoid, these have to be parallel. So notice we have an acute angle that's 70 degrees, which means the obtuse angle, the angle A, so 70 plus the angle A has to add up to 180 because they have to be supplements. So the angle at A has to be 110, okay? 110. Now part B, find the length of MN. Okay, so they want this length. It's kind of sneaky, so let me see if I can figure this out here. This is a sneaky little question. Okay, so we know that we saw a minute ago how this mid-segment works. We've got this length, which is 18, this length, which is 30, and this is our mid-segment. I think I'm going to skip this part too because I definitely didn't give you enough information today to kind of figure that out. So we'll skip that and we'll come back. All right. Great job, guys.